Hello and welcome to yet another episode of C Programming. In this video, I'm going to cover 4 more practice problems: how to find prime numbers using functions, add integers using functions, how to calculate permutations and combinations using functions to calculate elements of a table. To watch this video, you need to know about functions. Links are available in the description below. As always, link to different problems will be available in the description below, so feel free if you wanted to jump between different questions, just click on the link. Let's start working on the first problem. Remember that an integer is called prime if its only dividers are 1 and the number itself. The first few prime numbers are 2, 3, 5, 7, and 11. 1 is not considered to be prime. Write a program that prints to a file the first prime n number of primes, where n is input by the user. Your program must utilize the function isPrime shown on the screen. Run your program for n equal to 9. Your output should look like what you can see on the screen. Let's jump into Visual Studio and start coding.
In step 1, I need to declare the function that I'm going to use in the main program. So we'll just go ahead and tell the C compiler that I'm going to have a function which its name is isPrime. It will return the integer, and the input is also an integer. In this case, the implementation of the function was provided to us by the question. So I'll just copy paste the code here. Please note that the comments before the function is important. If I read the comments, I know how the function would work, and I don't need to go over the function and see what exactly would be the way that this function would work. Just by reading the comments, I would know that the function will return 1 if the input parameter is prime, and will return 0 and if the input parameter is not prime. The next step is to declare the variables. I need an integer, let's call it number of primes. I need an iterator, as I will need a loop as well. I need a counter to keep track of the primes numbers that I printed. I also need to open the output file for writing. The next step is to prompt the user to enter the number of primes to find. I'll be using the printf function and scanf function. I know you guys are comfortable doing this. Now I'm going to print the headers of the table. First, I'm going to print it to the screen, then we can easily change it and forward it to the file. In this step, I will loop through the integers starting from 1, as I know the function isPrime can handle the integer 1 as well, until the point I find the number of primes the user requested. Let's initialize the iterator. I'm going to comment the code in step 3 and hard code number of primes equals to 9 just to test my code. I will change it when it's all done. I'm going to create a while loop. The condition is while my counter is less than the number of primes user asks, continue the loop. Inside the loop, I will check the iterator to see if the integer is a prime number or not. As you can see on the comments of the isPrime function, if the number provided is prime, the function will return 1. And in the next step, I have to increment the iterator. You can see the picture. The loop will continue until the variable counter is no longer less than number of primes requested by the client. Let's debug the code to see if it is working. I will put a breaking point on the while statement. You can see that the value of the variable counter only changes if the return value of the function isPrime is 1. And it is what we expected. Let's add a printf statement and print the output to the screen. Now that it is working, let's modify it and print the output to the file. I just need to change the printfs to fprintf function and add the file pointer to the function as well. As you can see, I've been prompted to enter the number of primes to file, and the output has now been printed to the file. The final step is to close the file.
I hope the solution is clear. Let me know if you need more help. I'd be glad to help you. Let's jump to the next problem. As you can see on the screen, the problem is asking us to write a program which reads an integer n from the user, then calls a function, sumfunc, which sums the integer from 0 to n. As in question 2 in practice problem set number 4, your function should be able to handle both positive and negative values of n, but shouldn't write the result to an output file or print it to the screen. The result should be returned back to the main function, which then prints it to the screen. run your program twice with values of -10 and +5, and for example, the sample output should look like what you can see on the screen.
What I would like to do is to copy the code we had before for practice problem set number 4 and see how can it change it and use functions. Before declaring and implementing the function, I want to add the function call to my main function. This would better help us understand the input parameters of the function and the type of the return statement. As you can see, the sumfunc function will replace the selected code. First thing to do is to declare the function. I know that the function inputs an integer. It also returns an integer. And I also name the function sumfunc as stated in the question. The next step is to implement the function. I'd rather put my function implementation after the main function. I'm going to start with repeating the function declaration, then open and close the curly brackets to add the body of the function there. Now what you have to do is to move the code in the main function to the body of the sumfunc function and check to see if it works or not. Of course, you need to make some modification in order for the code to work, and you need to return the proper output.
I hope the hint helped you solve the problem, but as always, you can count on us, send us your question, and we will do our best to help you. Let's jump to the next question. The number of ways of arranging our objects chosen from n, where order is important, these are called permutation. The formulation is available on the screen. Also, the number of ways of choosing our objects from n without regarding to the order, called combination. Again, the formulation is available on the screen. So the question is asking us to write three functions, func, perm, com, that calculates the factorial, permutation, and combination, and returns the result to the main program. The main program prompts the user to enter the values of r and n, then prints the values of r, n, permutation of r and n, and combination of r and n using functions perm, r and n, com, r and n, to the output file, perm, com, out.txt. The functions perm and com will call the fact function in order to calculate the factorials they need. And the input output should look like what you can see on the screen.
I'm going to break this into different steps. Step 1 is to declare your variables. Step 2, open the output file. Step 3 is to ask the user to enter r and n. Step 4 is to use perm and com functions to calculate permutations and combinations. And step 5 is to declare all the functions. Step 6 is to implement the functions. Step 7 is to print the output to the file. And step 8 is to close the file. I'm going to jump to the function call step. I will call both perm and com functions to calculate permutations and combinations. I can see that my functions input two integers and return an integer. In step 5, I'm going to declare both functions. Next is step 6. Let's start working on the body of the function I just declared. I'm going to create an integer result, then calculate and assign a permutation and combination to these integer variables based on the formulas provided in the question. I'm just going to use the fact function here. Bear with me. We will declare and implement the function together. Then I'm going to return the result. One thing I wanted to mention here is that the code we wrote is working, but to make it more optimized, I could just go ahead and return the result of the mathematical operation rather than storing it in an integer, then returning that integer. Okay, we clearly need another function fact, which calculates the factorial of an integer number. I'm going to jump back to step 5 and declare the function. Then implement the function in step 6. I'm just going to create a for loop. The loop goes from 1 to n and multiplies all the integer numbers from 1 to n together, and store the result in the variable factorial. Of course, you see that the factorial had to be initialized by 1. Then, after the loop, we can return the variable factorial and the job is done. The code is working, and you would pass a test using this code. But imagine we wanted to optimize this code. By debugging, I can see that the first loop is just 1 times 1 equal to 1. That is unnecessary. So I can start from 2. On the other hand, in the condition of the for loop, I have two conditions, I less than n and I equal to n. This is 2 checks rather than 1. You might suggest we can change n into n plus 1 and get rid of the equal sign, but it's still not good as we are calculating n plus 1 in every loop. One solution is to add another integer, let's name it n plus 1, and say that it is equal to n plus 1 and use that in the loop, but it's going to get messy. The approach I like here is to reverse the loop. This is the one with programming. It allows us to think outside the box. And I can also go ahead and modify line 33 as well and optimize that.
I hope the hint helped you guys tackle the problem. Let me know if there's any problem. Next problem is similar to what the problem we did in the last video, but this time the question is asking us to do it using functions. Let's jump into Visual Studio and see how we can fix it.
I'm going to divide this into different steps. Step 1 is to declare your variables. Step 2 is to open the input and output files for reading and writing. Step 3, print the header rows of the table to the file. In step 4, we will develop a while loop to read each line of the input file and calculate the area, moment of inertia, and the section modulus, and print the output line to the output file. Step 5 is to declare all the functions. Step 6 is to implement the functions. And step 7, which is the final step, is to close the files. I'm going to jump to step 4 and create a loop which reads all the lines in the input file. Then I need to calculate the area, moment of inertia, and section modulus. Now that we know the function, let's go ahead and declare our functions in step 5. All 3 functions takes 2 integers, base and height, and returns a float number. In step 6, I'm going to implement my functions. The same way, you can complete the body of the inertia function and modulus function.
I hope the hints help you solve the problem, and if you need any help, don't hesitate to contact us. I'll be glad to help. This concludes today's video. Thank you for watching, and as always, see you in the next video.